Bien, muchachos, buenos días. Les damos la bienvenida a la charla del profesor Terrence. Ah, el doctor Chambers trabaja en la Universidad de Luisiana. Es una universidad con la cual tenemos una muy buena relación académica. Eh, y pues sencillamente el profesor Terrence nos ha acompañado ya, esta es la tercera vez que nos acompaña en la que, en la versión del Congreso. La tercera vez que nos acompaña en el Congreso. Hace un año estaba en la universidad, no, hace 2 años estaba en la universidad y bueno, aquí lo podemos encontrar con una charla de los adelantos que ha hecho en este tiempo. El profesor Terrence es el director del Laboratorio de Eficiencia Energética de la Universidad de Luisiana, el cual está compuesto por diferentes unidades, la cual me imagino nos va a dar una pequeña introducción. Así que, pues nada, sencillamente los dejo con el profesor Terrence. Cualquier pregunta es bienvenida por el chat y háganla sin miedo que yo voy a intentar hacer la traducción de la presentación. Así que, pues nada, los voy a estar acompañando todo el tiempo. Profesor Terrence, you can start now, please.
Okay. Well, first of all, I'd like to say thank you for the opportunity to visit with you today. I'd like to speak about hour-ahead floating photovoltaic power generation forecasting using multivariate ISMDEN SEGRU models.
Bien, les da las gracias por invitarlo el día de hoy, que estamos agradecidos por estarlo. Y hoy vamos a ver un proyecto de predicción de generación de paneles solares fotovoltaicos de manera anticipada, usando el modelo de Iceman SR Group multivariado.
And I would like to recognize my graduate student, Mohammed Atikur Rahman, who's actually doing this research, and my fellow faculty members here who are also advising the student.
Me gustaría reconocer a los estudiantes que están haciendo su grado doctoral, Rahman, y los otros compañeros que están colaborando en el trabajo que se va a presentar, que se está presentando.
Before I get into the heart of my presentation, I would like to talk just a little bit about the Energy Efficiency and Sustainable Energy Center, for which I am the director.
Antes de comenzar, me gustaría dar una pequeña introducción acerca del instituto del cual soy director, que es el Centro de Energía y Eficiencia de Eficiencia Energética y Energía Sustentable de la Universidad de Luisiana.
Our mission is to enable economic growth by providing world-class renewable energy research, workforce development, and outreach.
Nuestro objetivo es generar crecimiento y proveer conocimiento acerca de la energía, hacia la investigación de la energía renovable, trabajar en el desarrollo y en la búsqueda de la aplicación de esta.
Our vision is to ensure the world will always have an abundant and reliable supply of energy from clean and sustainable sources.
Nuestra visión como centro es la de asegurar que la energía renovable sea abundante, o sea, utilizar de manera frecuente la energía renovable y suplir, o sea, generar fuentes limpias y sustentables.
Our goal is to perform world-class research to discover local solutions to global problems.
Nuestra investigación está orientada específicamente en dar soluciones a problemas locales de nivel mundial.
We take a multidisciplinary approach to our solar energy research, which is my particular area. And we have faculty who are experts in all these different areas, such as system engineering, big data visualization, water and sanitation, cybersecurity, energy management, building energy management, and materials. And we feel that by bringing these skills to the realm of solar energy, we can provide some unique insights.
El centro está orientado específicamente de manera multidisciplinar para trabajar en la parte que es la cual soy más fuerte, que es la energía solar. Trabajamos con sistemas de ingeniería, Big Data, eh, saneamiento y agua, ciberseguridad, manejo de, o sea, manejo de, bueno, emergency management, eficiencia energética y la edificación y materiales todos asociados para el desarrollo de la energía solar fotovoltaica.
And in this case, we're going to focus on water and sanitation. We're going to be talking about a floating solar power plant on a reservoir.
Vamos a hablar sobre agua y saneamiento. Vamos a trabajar sobre sistemas solares fotovoltaicos y plantas de sistemas solares fotovoltaicos en reservorios de agua.
We've been fairly successful, I believe, in our research and have been able to secure funding from quite a few different federal, state, and industry sources, and publish quite a few journal and conference articles, and graduate many undergraduate and graduate students. And we've had the opportunity to perform outreach for thousands of K through 12 students.
Professor Terrence, what is a K-12 student?
Kindergarten, that's,
okay, perfect.
Yeah.
Ok, entonces, hemos tenido diferentes resultados que somos relativamente buenos, basados en los soportes de diferentes empresas que se pueden ver ahí, con desarrollo de graduación de diferentes estudiantes en la parte de educación, desde la parte doctoral hasta desde cientos de niños de kindergarten en el proceso.
One of our research facilities we call the Photovoltaic Applied Research and Testing Lab. It is a 1.1 megawatt facility. It's one of the largest outdoor test facilities in the southeast part of the United States. We do make power for the university in addition to using it for research, workforce development, and outreach. And we save the university approximately $10,000 a month on our electric bill. And the CO2 offset from this renewable energy is equivalent to planting 68,000 trees in the 3 years that we've had the plant operating.
En uno de nuestros más importantes elementos en el instituto, en el centro, es el laboratorio PART, que es Photovoltaic Applied Research and Testing. Entonces es un laboratorio para probar partes de sistemas fotovoltaicos, el cual es un laboratorio de 1.1 megavatios que está orientado a suplir el consumo energético de la Universidad de Luisiana en Lafayette. Ha disminuido el costo energético en más de $10,000 al mes y ha generado un impacto equivalente en la reducción de CO2 a la siembra de 68,000 árboles.
We also study concentrating solar thermal power, or CSP, and we have another facility which we call our Solar Thermal Applied Research and Testing Lab, and it's one of the largest university-owned CSP test facilities in the United States, and one of only a few in the southeast part of the United States.
También tienen otra facilidad, otro centro, otra parte del centro es el de el Kelco, is the name? Kelco is the name of the center?
Pico, yes.
Kelco, yeah. Kelco es la empresa que patrocina el centro. El centro es un centro de generación de energía solar térmica, donde pues sencillamente con energía solar se calienta vapor y se calienta el agua. Entonces sencillamente es otra facilidad para trabajar en el sistema.
We are just about to begin construction of, well, an expansion of that facility that I just showed to create a grid test facility, which will turn the facility into a microgrid, and it will tie all of our renewable energy generation resources together into a microgrid. We'll have a hardware in the loop simulator, and the idea is that we will be able to test various microgrid components such as solar, storage, electric vehicles, and other loads under realistic conditions, and simulate any type of load profile, commercial, residential, or so on, and simulate any type of generation profile such as wind, solar, or traditional.
Actualmente están trabajando en la ampliación del laboratorio en un elemento de simulador de microred para probar diferentes fuentes con diferentes cargas y pues sencillamente probar calidad de energía y diferentes condiciones de operación en el laboratorio.
Another line of research that we have is virtual reality, which we primarily use for education to teach sustainability to high school students. And we have created several virtual reality applications to teach solar thermal power, photovoltaic, sustainability, and we're studying the difference between virtual reality and 360 videos in that context.
Y en otro campo en el que se trabaja es en la realidad virtual para como soporte a la enseñanza. Se enseña la diferencia entre energía solar térmica y energía solar fotovoltaica en vídeos en 2D y en 3D.
We also focus on energy efficiency. Reducing the use of electricity is another way to promote sustainability. And so we and our students will go into a company and perform energy audits to help and make energy saving recommendations to those companies. And that is good for the company, and it's also good for our students because it provides very good training for them.
En otra práctica que se hace en el marco del centro es la de hacer auditorías de eficiencia energética, que es bueno tanto para las empresas como para los estudiantes.
And as part of that effort, we also have an HVAC laboratory where we study different types of HVAC equipment, heat pumps, water heaters, and so on. And we have a very nice environmental chamber for that.
Otro de los aspectos en los que trabaja el centro es en la parte de HVAC. HVAC es Heating, Ventilation and Air Conditioning, todo lo que es aire acondicionado, ventilación y calentamiento, donde tienen una cámara de control ambiental y bueno, y otras instalaciones que permiten evaluar cargas y otras cosas.
Another area of focus is workforce development to train the renewable energy workers of the future, including engineers, technologists, and technicians.
Otra línea de trabajo es la preparación de trabajadores de área, donde se genera generales, ingenieros, técnicos, para que soporten el desarrollo de las energías renovables.
And we have quite a few interested and exciting engineering students who want to study renewable energy.
Nosotros tenemos muchos estudiantes entusiastas para que estudien las energías renovables.
We've recently established a renewable energy minor in the College of Engineering, and we're currently in the process of creating a concentration at the undergraduate level, and we're studying the possibility for an undergraduate certificate and potentially a master's program.
Y nosotros tenemos un grupo de cursos que están desarrollados para la formación de estos estudiantes y están viendo la posibilidad de generar una certificación para que la vista de estos cursos se sirva como un certificado de formación a nivel de maestría. De manera personal, yo he visto algunos de estos cursos y algunos de los estudiantes en la universidad han estado en esos cursos y son muy buenos. I say that in personal opinion, some of students was participate in this course for invitation of parents.
Yes, and I'm going to mention that again in a moment. um, we have recently created several new solar energy courses, and we're focusing very hard on internships for our students and bringing solar energy representatives onto our industrial advisory board so that we can make sure that the curriculum that we're offering is relevant to the solar energy industry.
Están formando cursos que están orientados específicamente al apoyo del desarrollo de las industrias y del desarrollo de la energía solar fotovoltaica.
And one of the things that makes us the very most happy is to have a partnership with your university. And some of the things that we've done so far is team teaching of a solar energy system design class between Camilo and myself, my students and his students. Lectures such as this. We brought in industry speakers to speak to both of our classes. We've done class projects and focused on solving real world problems. And that's something that is very valuable to us. And we feel very fortunate to be able to have this relationship.
Una de las cosas más, de las cuales estamos más agradecido es la relación que hemos hecho con la Universidad Distrital Francisco José de Caldas, en la cual hemos compartido en manera de equipos de clase el desarrollo de algunos proyectos. Entonces, por ejemplo, en la clase que él dictaba, nuestros estudiantes mostraban los proyectos a los estudiantes de ellos pues sencillamente los estudiantes se podían desenvolver en uno de sus procesos en sus clases. Entonces eso para ambas universidades y de manera personal ha sido un trabajo bien bonito pues bastante gratificante. Thank you, Professor Torrance.
Thank you. It's my pleasure. All right, now I would like to start talking about the floating solar power plants and power forecasting. Floating solar power plants are a relatively new concept, but it's growing soon. It's growing quickly. They are a way to generate power that does not require the use of any land or any rooftops. And they have the advantage, usually they're located on a reservoir, and sometimes on those reservoirs, they use shade balls, floating shade balls, in order to reduce the growth of algae. And this a floating solar power plant can serve the same purpose. And instead of merely providing shade, it can also provide power. And it has higher efficiency than a ground-mounted solar energy system because of the cooling effect of the water. And the other advantage, of course, is that you don't have to use land.
The floating solar power plants o las plantas solares flotantes son un nuevo concepto en sistemas solares. Se ha trabajado hace poco y FPV son las iniciales y son una alternativa para conseguir aumentos de eficiencia en los sistemas de sistemas solares. Ya en un minuto el profe TERRENCE explicará el porqué de esto, y tienen varias condiciones interesantes, que la primera es que no utilizan ni el techo de las casas ni tierra útil, o sea, ni espacio útil, y adicionalmente evitan la evaporación del reservorio de agua y bueno, y aumenta la eficiencia del panel tal como les decía.
The floating solar power plants are most appropriate in countries or region where you have a high population density and many bodies of water. Right now, there are only about 350 floating solar power plants in the world, but the market segment is growing rapidly, and it's expected to be a 3 gigawatt per year market very soon.
Entonces, la población ha crecido bastante y sencillamente se ha aumentado la demanda de energía de una manera eh, muy rápida. Y pues sencillamente la idea es utilizar estos sistemas solares fotovoltaicos para cubrir esa demanda.
The goal of this project was to apply a machine learning, a deep learning technique in the new domain of floating solar photovoltaic systems to predict power generation.
El principal objetivo aquí es sencillamente aplicar y aprender profundamente la técnica del comportamiento de los sistemas solares fotovoltaicos para predecir la generación de energía eléctrica.
And what are we hoping to achieve, or why is this important? It's difficult to estimate the power generation from variable renewable energy sources because the solar resource and other environmental variables such as wind and ambient temperature and humidity, they're all very variable. And so that makes them difficult to predict. But utility companies need to be able to, especially in the United States, I don't know for sure how it works there, but they need to bid into the regional energy markets on a day ahead basis and on an hourly basis during each day. And in order to make reasonable bids and be able to make money, they need to know how much renewable energy can be generated a day ahead or an hour ahead from now.
Bien, ¿qué es lo que queremos lograr? Sencillamente o qué es lo que tenemos como línea base. Sencillamente tenemos una dificultad para prever la cantidad de energía que se puede generar con los sistemas solares, con la energía renovable, porque depende de propiedades variables en el tiempo. Entonces, el viento, la cantidad de radiación solar y los cambios de esto, humedad relativa, la temperatura del medio, todos son variables que van a cambiar en función del tiempo y las compañías, pues sencillamente en el mercado tienen que tener certeza de cuánto es esta generación, porque pues sencillamente ellos están generando, ellos plantean un precio de generación en función, en base de horas. Entonces se necesita saber esa proyección de generación.
The things that are new in this study are that we have developed a hybrid approach for floating photovoltaic power generation forecasting, and we have compared these results to other models to help reduce the inaccuracies of the predicted and the measured data.
Entonces lo que queremos verdaderamente o que lo que queremos contribuir es sencillamente a generar un modelo de previsión de la cantidad de energía que puede proveer los sistemas fotovoltaicos flotantes y comparar modelos predictivos para que comparar y visualizar estos modelos para reducir errores en la predicción.
The particular floating photovoltaic plant that we studied is owned by a company called Sanepar. They are a water company or a sanitation company in Brazil. The plant is located on the Pasaúna Reservoir in Curitiba, Brazil.
La planta que estamos trabajando o que tenemos enfocados actualmente es la planta de Sanapar en Pasuna, Brasil. Esa es la que están trabajando actualmente.
And sensors have been installed to measure and monitor the solar power generation, the temperature, humidity, irradiance, wind speed, and wind direction.
Entonces tiene sensores que pueden medir la generación de potencia, temperatura, humedad, irradiancia, velocidad de viento y dirección de viento.
The system is a 130 kilowatt system. It has 1,500 square meters of surface area. The tilt angle is 15 degrees and the azimuth is 0 degrees facing north. And there are a total of 396 solar modules, and each one is puts out 330 watts. And there are two inverters, a 60 kilowatt and a 50 kilowatt inverter.
Bien, yo creo que eso es, I think that this is clear. La planta tiene 130 kilovatios pico, tiene un área de 1500 metros cuadrados, 15 grados de ángulo de inclinación, un azimut de 0 grados mirando hacia el norte, 396 módulos de 330 vatios y un inversor de 60 kilovatios. ah, Dos inversores, uno de 60 kilovatios y otro de 50 kilovatios en la planta.
The modules have a very low tilt angle, and that allows the rows to be very close to each other. And the floats are made of plastic, and they just snap together and screw together with these plastic nuts, and they're very easy to assemble and install.
Y entonces la planta está montada sobre unos soportes plásticos que son fáciles de unir, se unen con esas tuercas plásticas y tiene un ángulo de inclinación relativamente bajo, de 15 grados, y pues están cercanos, lo que permite que la cercanía entre un ángulo, entre un panel y el otro sea bastante pequeña. O que la cercanía sea, sí, que estén muy cerca uno a los otros.
Now, in order to make an accurate prediction of solar power, we have to make, we need that in order to be able to make correct financial decisions. But due to the uncertainty of the weather, it's very challenging. There has been a lot of work done for forecasting the production of ground-based solar and roof-mounted solar, but there's been very little done on floating photovoltaics so far.
Pues la apuesta aquí es conocer más sobre las plantas solares fotovoltaicas, ya que tenemos mucha información sobre sistemas fotovoltaicos que están puestos en piso o en techo, pero falta información para sistemas que estén en el comportamiento de sistemas que estén en agua.
Machine learning and deep learning methods are becoming very popular compared to statistical and physical models for the prediction for day ahead and hour ahead forecasting. And of course, solar power prediction is heavily dependent on historical weather data.
En machine learning and deep learning methods, estos dos métodos pues han ganado popularidad para el análisis estadístico y el análisis de modelos físicos para la predicción basada en días y en horas.
The method that we're going to use is a hybrid method. And what we're using is something called an improved complete ensemble empirical mode decomposition adaptive noise, or ISEMDAN. And we're also using sample entropy and gated recurrent unit, GRU, for the machine learning technique. And this hybrid method has lower root mean square error loss than other existing models.
Bien, vamos a usar un método o van a usar un método híbrido que está compuesto por dos modelos o dos modos. El primero es el modo de descomposición, de descomposición adaptativa del ruido, presentado por Eisner, ¿verdad? Y algo así, y un ejemplo de la entropía, acompañado de una entrada recurrente de unidades, la cual tiene una pérdida pequeña de ruido en los en los modelos existentes. Entonces, la idea es que hacen la conjunción de estos tres modelos precisamente para reducir el ruido de cada una de las variables.
This diagram on the left shows how these different pieces are used to create the model. We begin with normalized multivariate data. This is the weather data that is the input to the model. We take about a year worth of data, and then we decompose that year's worth of data into several smaller groups of data that have similar characteristics. For example, cloudy days have similar characteristics, and sunny days have similar characteristics. So we decompose the year's worth of data into smaller groups of similar data.
Bien, entonces el gráfico que se ve ahí sencillamente explica cómo es el proceso de explicación. Entonces se obtienen las variables normalizadas y lo primero que se hace es utilizar el modelo de descomposición, el ICE-DAN, agrupándolas por características similares. Entonces, sencillamente las características del día soleado, las características de días nublados, y sencillamente las descomponen o las agrupa en el modelo.
These groups of data that have similar characteristics are called intrinsic mode functions, or IMFs. And we have several of those that are generated by the ICE-DAN decomposition process. And then we select the best ones using the sample entropy method, or the SE method. And we use those groups of data to train the machine learning model, which is the gated recurrent unit model.
Bien, ese grupo de variables que tiene el Iceman-Dan, ese grupo de variables que sencillamente genera unos nuevos módulos de función, los cuales se utilizan para hacer aprendizaje en la máquina mediante el método de ejemplificación de entropía sí, una ejemplificación entrópica.
And then, yes, so we use that method to train the model, and then we use the last 24 hours or the last 6 hours or the last 4 hours of actual weather data in today to predict what will happen tomorrow.
Entonces enseñamos con esos grupos de variables, nosotros entrenamos al sistema para que vaya aprendiendo qué es lo que está pasando en el día anterior, en módulos de 6 horas, 12 horas, 24 horas, para ver, en función de lo que está pasando, qué va a pasar el día de mañana.
Why do we use this hybrid method? It's because it gives us lower root mean square error than other models. And also because time series data can contain a lot of noise. And by decomposing the data into these smaller groups of similar behaving data, we can extract the noise from the original signal, and valuable features can be extracted from it, such as the trend and seasonality and so on.
Y entonces, ¿por qué usamos este método? El primero es porque tiene un error cuadrático medio relativamente bajo comparado con otros modelos. y adicionalmente reduce el ruido que tienen las señales que varían en el tiempo, como son las señales climáticas. Ese ruido, pues sencillamente esa variación que generan todas esas señales, sencillamente las trabajan mejor.
Okay. The Eisendan method is an improved method over an earlier method called EMD, and it takes less time and has better error than the previous method. And we, in order then to improve the method even further, the Eisendan method decomposes the data into several groups called intrinsic mode functions. And those, the best ones of all of those are selected using the sample entropy process. And then those groups of data that have similar features are fed into the deep learning neural network to train them.
Bien, entonces el método de Eisendan es mejor que el método anterior, que el método empírico de descomposición, porque pues sencillamente toma menos tiempo y tiene tiene un mayor error medio o sea, tiene menor error medio que el método de Eisenland. Entonces es una evolución del método. Adicionalmente, pues sencillamente genera esa generación, esa descomposición genera esas funciones que al ser combinadas con el método de simplificación de la entropía, pues sencillamente pues genera un mejor entrenamiento para el aprendizaje de la máquina.
There are two prominent algorithms, machine learning algorithms for this type of sequential time series data, GRU and LSTM, and we found that GRU performs better for this particular application.
Y aplicando los dos algoritmos, el GRU y el LSTM, pues sencillamente son algoritmos que van a tratar mejor el análisis de las series para obtener mejores comportamientos en la planta.
Okay, here are some of the steps. The steps begin by first identifying, for all of the data that we could use, identifying the ones that are most useful for our prediction. And so we considered all of these variables in the top, and then we eliminated the ones that had a low R² value, such as these here and this. And these are the variables that we ended up using right here on this side. And you can see how they vary with time over the year.
Lo primero que se hace es hacer como una especie de análisis de las variables que se pueden utilizar para el sistema. Entonces, sencillamente se empiezan a quitar algunos datos pues, que generan ruido, que son raros en el análisis o que sencillamente no colaboran al análisis. En ese caso, pues presentados ejemplos pues, en la irradiancia. Y lo que se muestra a la derecha, pues sencillamente son los datos o la toma de datos normalizadas o revisadas que se tomaron y que van a entrar al método para ser analizadas.
So here's the method. If you look over here, the first step is to prepare the data. We collect the data from the actual power plant, and then we clean the data to make sure that we take out all of the days where there was a bad recording and so on. And then we decompose the data using the Eisendan process into these different groups of data that have similar characteristics. We then normalize the data so that it all is between 0 and 1. And then we feed that data for similar days into the machine learning models, and then we make a prediction, and then sum all the predictions, and then we compare we've done this for several different algorithms, and we've compared the results, which I'll show you in a moment.
Perfecto. Entonces, lo que hacemos es en Data Collection, el Data Collection son la colección de los datos en planta. Luego de eso hacen un Data Cleaning, que sencillamente es una limpieza de los datos, quitando los datos que pudieron tener algún error en la medición o algo que sencillamente no esté bien en el modelo por X o Y razón no en el modelo, sino en la medición. De ahí entonces entramos a la a la descomposición de datos por el modelo de ICMDAN y ese modelo pues sencillamente me va a generar los grupos de datos recurrentes o regularizados o característicos que tienen un comportamiento similar. Ese grupo de datos recurrentes me va a dar grupos específicos a los cuales se va a hacer una normalización, se le va a hacer un análisis de datos y se va a generar una predicción. El conjunto de esas predicciones me generan una sumatoria de predicciones totales y una vez que tengo esa sumatoria, pues obtengo un modelo comparado o una comparación de los diferentes modelos para generar esas predicciones. Es decir, yo miro lo que está pasando actualmente para evaluar en función de lo que pasó anteriormente, cómo va a pasar el día de mañana.
This graphic shows an example of, for one of the variables, which is humidity in this case. This is the original data in the top figure here for humidity. And this shows how it has been decomposed into 6 different intrinsic mode functions, IMFs, and that each has similar characteristics. And this is what we did for all of the variables. This is the output of the decomposition step.
Ok, entonces tenemos varias cosas aquí. La primera, eso es un ejemplo de la humedad, un ejemplo de la variable de la humedad que ha sido, en la parte de arriba se ve la señal original y después tenemos la descomposición en los diferentes grupos, de 1 hasta 6 grupos específicos. De esos 6 grupos, pues sencillamente se obtiene o sea, se obtiene la respuesta de la generación. Es como el ejemplo de la descomposición. Professor Terrence, we have a little time. I don't know if if you need more time. Or how much time do you need for finish?
Actually, I've got just a couple more slides. We could just finish in about 2 minutes if you would like.
Okay, thank you, thank you.
Yeah, sure.
Sorry for that.
So after the decomposition, then the data is used to train the machine learning model.
Este es el ejemplo de cómo se entrena la máquina con los datos que se obtienen.
Yeah, this is this figure describes the machine learning model here on the right, and so the data from the previous slide is fed into this machine learning model, and it is used to it trains the machine learning model, which is a neural network. And so the data is used to train this neural network. And then once it is trained, then we're able to make our predictions.
Bien, entonces sencillamente con esto entrenamos la máquina. La idea es que entra las matrices y se va entrenando la máquina con con esta, con esta gráfica de flujo. Y pues sencillamente la máquina va aprendiendo en función de los datos que va obteniendo y los datos que obtuvo antes.
Okay, I think I'll skip this and go to the results. We did this both for a single variable and a multivariable analysis. We found that the multivariable analysis provided the best performance, and we compared several different machine learning algorithms, and the one that performed best is the ISMDN SEGRU.
Lo que podemos ver es que el modelo híbrido genera mejores resultados con un muy buen resultado de error. comparado con otros modelos, ya solamente uno solo o pues el híbrido me genera mejores modelos y más rápidos.
This is an example for for 4 days in August of this year, and it shows how the model, all these different models predict the performance.
Este es un ejemplo de 4 días de agosto en el que se puede ver el comportamiento del modelo y de diferentes modelos, ¿no? Entonces el modelo el modelo que he utilizado y el modelo real.
And what we found was that the ISMDN SEGRU model performed better than all of the others in terms of lower root mean squared error and higher R squared values. The training time was relatively long, but then once it was trained, it performed better than the other methods. And we think that that justifies its use.
Qué pena. Entonces, de nuevo, se puede ver la buena participación del modelo, del modelo híbrido con respecto a otros, con un menor error, aunque sí toma un poco más de tiempo. Creo que ahí me equivoqué en la anterior slide. Entonces, sencillamente, sí toma un poco, aunque toma un poco más de tiempo, los resultados en el error son relativamente buenos.
Okay. So in summary, we found that the ISMDN method can decompose the signal, and then SE can recombine the similar INFs to form a new IMF. We found that the hybrid model works, the hybrid multivariate model works the best. We found that GRU works, is the machine learning model that works best. And we did get good results, but we do feel like we could improve it later.
Bien, entonces los resultados generales, pues sencillamente es un resultado de lo que hemos visto en toda la presentación, que es que los modelos híbridos, pues sencillamente me generan mejores comportamientos de las variables y me dan una buena proyección de las variables en el tiempo.
Okay, that's it. Thank you very much. Does anyone have any questions, or do we even have time for questions?
Listo, y entonces sencillamente, si alguien tiene una pregunta.
Let's see.
Gracias. Thank you, Professor Terrence, for your presentation. Le estaba diciendo a Carol que vamos a tomar 2 minuticos, sí, Carol, 2 minuticos, 2, 3 minuticos. Entonces, the first thing is thank you for share your experience. I know that you go to Brazil a few days ago to visit this plant, and the purpose of this talk is that you show your experience and your all your knowledge about these things. One question: Do you think that it's possible replicate this kind of plants in Bogota? Bogota, do you know Bogota? Bogota is cooled. The temperature of the environment is cooled, and you put in the water. You have found lower temperature in this kind of application. And the other question is, is possible found good results with a lower plant, with a plant with lower power generation. For example, for make an example in the university with 2 or 3 panels, uh, do you think that it is possible found good results for start a new project or something?
So in answer to the first question, whether the floating solar power plants are applicable to Colombia would depend, I think, on an analysis of the specific site. When it comes to floating, I think that one of the things that you don't want to have happen is I don't think you want to have the reservoir freeze. So if it freezes, that could cause a problem. So I don't know, do your reservoirs freeze?
No, because no, and ever.
Okay. Okay. Well, then if that's the case, then probably you could do it. Yes, I think you could do it. And the question of where to do it, it would be where you have a load. For example, this one is co-located with the pumping station of the sanitation company. And so it provides the pumping power to pump the water from the reservoir. So that's a good application.
And the second question about
the second question is, could you do with a few modules, could you do a demonstration at the university? Yes, I think you could. The interesting thing, well, the challenge, the challenge would be to get enough water that would be at the correct temperature, the same temperature as the water in the reservoir, because it's the cooling effect of the water that provides the increase in efficiency for the floating solar power plant. So if you had a very small water, a very small thing of water, it might get too hot or it might not be representative, but it would probably still show some improvement because there's some evaporation probably that would happen and probably would cool the modules and allow them to operate more efficiently. I would think so.
Okay, Professor, thank you for your talk and thank you for your time. Please give you a good Black Friday today.
Yes, thank you.
And your budget will be a very good budget, and thank you for this talk, and I see you in the next meeting.
Yes, that's right. I hope to see you up here very soon, or me down there.
I hope that.
Okay, thank you very much.
Thank you for Professor TERRENCE. Bye bye.
Thank you. Bye.
Listo, Carlos, gracias. Muy amable. Chao. Qué pena por la demora.
Balamurugan Balakreshnan. Bueno, yo le digo Bala. Su tema, digamos, es computación en el borde. Él es una persona que trabaja con Microsoft a nivel de liderazgo en transformación digital con inteligencia artificial y soluciones digitales basadas en la nube. Él proporciona liderazgo en aprendizaje automático, IoT, Big Data y soluciones analíticas avanzadas. Tiene un amplio conocimiento en tecnologías de fuente abierta de Microsoft y otros proveedores de nube. Brinda tareas de liderazgo y análisis desarrollados con el fin de, digamos, de generar soluciones. Diseña soluciones de principio a fin en la nube y desarrolla el punto de vista de las soluciones en que está el punto de vista empresarial, de la información y la tecnología, haciendo una síntesis. Fue un poco complejo como conseguirlo y esperemos que su charla, que sé que vamos a sacarle mucho provecho, pues sea vital para toda la audiencia. Bala, ready. Okay, after that is your turn. Please, please could you start, okay?
Thank you, Alberto. Hi, everyone. So my name is Bala. As the professor said, I work for Microsoft. I've been working here for more than 5 years now, mostly on the digital transformation side, which is basically like doing industrial IoT, how AI can affect IoT, and how we can actually build applications on the plant floor, or you can build commercial applications, whichever way we can. So I've been doing that for the past 5.5 years. I do a lot in industrial IoT and AI. I also do a lot of public speaking in conferences as well. If you guys have any questions, please feel free to stop and ask me. So Alberto, how much time do we have?
45 minutes.
Perfect.
I am thinking in translate, but no. Please talk, and I'm trying to do the summary.
Okay. So first of all, thank you everyone for coming in for the conference, and thank you, Alberto, for having me here. So let's talk about what is happening. As technology is growing, especially in that IoT space, IoT has got two flavors. One is the regular IoT, and then the other one is the industrial IoT. Regular IoT is the commercial industry, like the Fitbits that you're wearing, or if you're getting a heart monitor or a cardio, like the mobile app ones. Those are considered like mostly consumer IoT. That's just one part of it. Then the industrial IoT is where most of the challenges that we see, because industrial IoT needs a lot more, brings in a lot more data and need to work with a lot more data as well. But what is the use of just having a cloud, right? So Microsoft is working on a hybrid architecture, and I'll show you some samples how we do that. But why are we doing it? Is because we are getting a lot of our customers are asking this, what's happening in this space, and how can we use the current new technologies and make their businesses better, mostly in manufacturing around the OEE KPIs, like operational equipment efficiency, like the productivity, uptime, and availability and downtime. Those are always been focus of what customers are always asking about. But not only that, there are others: employee safety, quality, predictive maintenance. They want to bring in new things into the manufacturing, including at this day and age supply chain, which has been which at least been projected as a problem these days. So we came up with a solution that actually can cover intelligent cloud, which is what we call our Azure. And then how can we extend that with an intelligent edge? We don't want to build data centers at the edge, which is what usually the manufacturers used to do. But we wanted to bring in a minimal footprint, like a consumable pay-as-you-go type model, and do the heavy lifting in the cloud. Now, you can ask me why. Here are some of the, this is basically the marketing point. I mean, why we go invest on all these things is like, we are looking at the market and this is what is happening. IoT and industrial IoT, depending on what you're looking at, used to be a technology before. Now it is a mainstream, which means everybody in some way or fashion, they are looking to do this. It could be in a small scale and then people are growing, but I have seen a lot of adoption in the past few years, especially this year. Now, there is a reason why I also said like AI is part of here, because AI is going to be one of the value generator for industrial IoT. So that's why the concept of AI plus IoT is coming together. We see a lot of adoption, as you see on the screen here. The bottom one is the most important one. It's going to drive like extensive growth in the data that we are going to collect. Usually in manufacturing terms, the data has been collected, but it always goes to the historian, which are sitting inside the plant itself. Some people do have it centralized, but here, the industrial IoT is going to change that game as well. Now let's talk about some of the challenges what we had. If you take about a hybrid landscape, most of the challenges that we see is the infrastructure, then is the network, and then the data. Given infrastructure, you can only scale so much because of the location where it is. Manufacturing plants are not usually it's not in the city, right? It's always somewhere in the outskirts of the city, and your facility has certain size, so you can only put so much of server in there. And then you have the network bandwidth, like you need internet, you need to connect, you need to have providers to come and put network connection into it. And then all the data that is collected in the floor by MES and MOM systems, they always stay in there. These are all some challenges because you can only save, store so much data in the data center itself. Now let's talk about what challenges we face in the cloud with the IoT edge. Here also we have some things, like if you see the data part is gone, which is why data is what is going to help these companies to build their future and make money out of data. But there are still some of the other things like connectivity, cost, the network bandwidth. Network bandwidth is one thing that I've seen time after time. So this is why technologies like 5G comes in play, which is extremely helpful. Security is another very important thing. I mean, until now, the security is within the facility, so it was okay. But now, if it goes to the cloud, we need to look into that. And then comes the latency. How quick can we get actually a packet sent from the manufacturing floor all the way to the cloud and get it back? And there is a reason for it. There are certain things, if you want to take millisecond level in manufacturing decisions, like as the line is moving on, it would be hard for you guys to send it to cloud and get it back. Rather, have an edge that can perform locally and do the calculation and take the decision right then and there. And then send the data out to the cloud so that the edge can do its compute. It's not bogged down with the data, whereas the data is pushed to the cloud. So there are things like that we are working on, and that's how we can design as well. So these are some of the challenges that really we see in terms of what's happening in the industry. Now, here is a very simple example of like how an architecture it would be. If you look at the left side, we have Azure Stack Edge, which is what it's a common terminology that we use. We have different type of edge devices, like small devices to up to a rack server, and there is a reason for it. So the small devices can be connected to a PLC or a control system, and pull data and send it out. But if you want to run a local MES and things like that, that might be an overkill. So you can actually get like a rack server. It's a single rack or a double rack full of servers. We call it Azure Stack. But you can also get like individual units, like 1U servers to do inferencing for audio, video, and stuff like that. And I'll show you guys that. And that's because of this low latency and immediate prediction inside the factory itself. So the idea is you won't do any heavy duty data processing, but you will do heavy duty data collection, send it out to the cloud, but you will have like machine learning models which are deployed in the edge, which will allow you to take decisions. You're not going to create the model there. You're going to only use the model, which we call the inferencing side of it. And you also can do like immediate root cause analysis, alert generations, condition-based monitoring, such things near the edge itself. Usual idea is like you can store up to 6 months of data. And if you have a stack, like a server in a racks, usually I have seen MES 6 to 1 year is saved in the on-prem, and then remaining everything is pushed to the cloud. Now you can collect from any different type of sensors. It could be autonomous vehicles, or it could be a manufacturing line, a station, or an entire line, or individual line machines, which is stations, or any other movable objects or fixed objects like temperature or inventory and things like that. Now, that's just one part of data collection and immediately visualizing it like dashboarding. We also allow you to do the deploy cognitive services. So you can do like voice recognition, speech to text, text to speech, or you can do OCR locally, or you can do custom vision, which I've done a lot of projects on using, instead of advanced optical inspection, we use AI to look at it and tell whether the product is damaged or not, for quality control mostly. And then you use SQL Edge to store. We'll talk about the technology part later, because we're making it much easier. Now on the right-hand side is where the cloud comes. And as soon as you talk about the cloud, I mean, so far, does it make sense? Yes?
Yes, yes, no problem.
Perfect. So the right side is the cloud side. Now, cloud side is where you do all your heavy duty analytics or logic processing, figuring out what happened, what is not happening, what if analysis, root cause analysis, and things like that. This is where you get the scale when you need it. Most of the our platform as a service components, we call it PaaS, they're all based on pay-as-you-go model, and also you can scale when you need. You don't have to pre-plan it for like 5 years and all. You can just plan for 6 months, start the project, and if you grow, then you can increase it. If you're not, you just keep it at the same low price. And you can always have control over it. These are some of the components that goes behind the scenes, how you can build your application. It could be a real-time monitoring, or a predictive maintenance, or an MES, or a traceability, or even for that matter, supply chain forecasting and things like that. Depending on which software you're going to use, you'll pick and choose which services to use. And yes, this becomes very confusing in long run as well. And we'll talk about that. And I'll tell you how we are making it much easier for you guys. So let's talk about the edge a little bit. There is a product called IoT Central that I'll get to you later. But what we are trying to do is we are trying to make the edge communication more and more secured and easy to use. Our IoT Edge is based on a software component, and it basically runs like a Docker container. And we also allow you to manage the Docker containers, what modules to go in from the cloud itself. And we have very good security. We use TLS, and we make sure that everything is getting handshaked and encrypted. And every device is authenticated for every packet. We maintain a device registry. We have a lot of way of authentication. One is the SAS token method. The other one is the certificate-based mutual authentication. This is the one that is getting a lot of attention. The third one also, certificate-based mutual authentication with the certificate authority. For right now, we have a device provisioning service that allows you to take certificate from like vendors from, I forgot the name. It's not the very sign, it's the DigiCert. DigiCert. You can buy certificates and you can authenticate using certificate each edge device, just to make sure that there is nobody's tamper proofing or anything like that. Now, that being said, we also have permissions and role-based access and action-based security, all embedded in the IoT Central on a per device level of however you're implementing the IoT edge. So in a manufacturing plant, if you take industrial IoT, there could be one or there could be many edge devices depending on what we are using. And then we have the concept called device twin. Device twin is nothing but an ontology representation of what the device is and its properties. We usually call that as a configuration parameters. So you will know when the last time it got applied and what was the last set of values alone. It doesn't store the history in there. And on top of it, for IoT edges, we are providing hardware level security. We do have an IoT edge security manager. You can bring your hardware secure module and use that also to connect to the file system and make sure that the device is secured as we speak. You can also do that in a hardware level also. There is a HSM and TPM also. You can also use the TPM, which is like the chip-based, to control the security element of the HSM itself. If you're building in hardware, edge hardware, they usually look at the TSM. That's the manufacturers are embedding inside there so that it's very secured. If you're buying something for IoT edge, we do have a catalog of devices that you can pick and choose from. Every one of those devices will automatically have this base security and all built in for you. All this to make sure that only this device is communicating, not somebody acting like this device is communicating. That being said, this is the logical model that we use. We have an HCM where your logic sits in securely, and then we authenticate that, and then the abstraction layer actually is connected through an API. And then again, we also have an IoT edge security daemon, which actually runs through and make sure that everything is secured. It actually scans and reports it into IoT Security Central. This is very important since the cloud, and as you guys probably know, like the hacking that is happening, just to make sure that things are in the right order and safe. That being said, what else do we have? So we have this hardware root of trust. We also have secure boot updates. You can do secure execution environments, and it also protects the general computing. Now, all these are available in Edge in the form of SDKs. So it tries to abstract and give you the features that makes your device secure. But again, the business logic and what needs to be done is something that you guys have to write the code on. So on the right-hand side, if you see, if you know the ISA 95 model, the bottom, IoT Edge serves in that, and the bottom second layer that collects the data. And then you have a security manager. Every IoT hub will have a security manager, which connects to actually to the Sentinel to know like if anybody poofed it or anybody is trying to attack or any DDoS attacks are coming in and things like that. And then that gets connected to the IoT hub, which is part of the IoT Central. This is how we actually do the hybrid architecture. so that the edge is always secure. And of course, cloud, we put a lot of money into being secure. Now, where we are seeing, like when you talk about these edge scenarios, right? Where are we seeing all these use cases coming out? Mostly in the manufacturing side, of course, asset tracking, inventory operation, remote operation, safety. Energy industry does a lot because they're offshore drills and things like that. They want to monitor and predict not only the smart grids, but also the energy producers also. The energy transmitter is also used for like grid monitoring and things like that. Healthcare is also another sector because manufacturing, healthcare, they both are very complex in terms of like, in a manufacturing plant, you cannot say like one software is what is running. Every line and every station might have different set of softwares that is doing the SCADA systems. So does healthcare also. But healthcare, they're using it for like patient's outcome, making sure that the patient satisfaction is good, not misdiagnosing and not coming back again and again. So a lot of those things. Retail is another one, but retail mostly in the supply chain side. And perishable goods and all, like if they want to track and if they want to do traceability extension for manufacturing, then that gets extended into the intelligent supply chain part of it. So these are some of the use cases, only a small set. There was a lot of slides on this, but I couldn't get it for you. But let me show you something that what close to your industrial IoT side is like. This is a manufacturing plant, and you can see I think it's a KUKA robot. Now, these robots can also can seamlessly be plugged in. As you can see, it can run Azure SQL Edge, which is basically an edge computer that is running a miniature SQL engine to store immediate data from the robot. And then actually it gets connected to the IoT edge. You can do anomaly detections locally because we have our cognitive services as anomaly detection API that can be containerized and pushed down. And you can also do real-time data munging, data processing, and alerting because you can take stream. There is a software called Stream Analytics services. And you can take that service, configure an alert scenario saying that, okay, if the temperature reaches about 80 degree centigrade or whatever Fahrenheit you want it to be, then send out an alert kind of thing. And then the remaining historical data gets pushed into the cloud because the edge can only hold a decent set of maybe like a month or 6 months worth of data set. Some of the, depending on these devices, you might have to figure out how much storage you need in the edge. Because I've seen some of these devices filling like 2 terabytes in one day. Now let's talk about what is the next thing that is coming. So far you saw everything was about industrial IoT. Now here is where it gets become very more interesting. We are bringing in a device called Azure Percept. It's an intelligent device. It's an IoT and an intelligent device, and I'll tell you why. The bottom part is your the edge component that I was talking about. You have the Azure Stack HCI at the right end, which is like a bunch of servers in a rack. And then the second one is we have certified partner products that are certified that you guys can buy as well and use it. And Azure Percept is our development kit. It's our new AI development kit, which is tied to IoT as well. You can use this for real-time video inferencing for object detection like forklifts or any oil spill or humans going in front of an upcoming forklift or autonomous vehicles, detecting things like that. You need edge power because the AI, if you want to use AI in the edge, you need GPU and you need to be able to do it faster. Like this device can do about 20 inferencing per second. It's pretty that fast, 20 frames per second, sorry. All those, if you look at it in the center layer, it can, on the left side, like on this area, if you see that you can actually add AI skills, cognitive skills. These are all our cognitive services. You can also do, we have a product called LVA, which can take video clips and store it, like for motion detection, checking and things like that. And the Percept device itself comes with like automatic updates that you can control and push, and it also gets maintained in the cloud as well. And then you can also add third-party edges to it. So this is our new IoT and AI ecosystem that is getting evolved. And the top part, if you see, is our cloud-based software. So you can do video monitoring, vibration analysis using your audio and things like that. Or you can also do video-based predictive like quality, product counting, or if the product is good or not, all those things. So this is our new platform, and this is the new, let me go back. So this is the, oops. Oh, so that's the device. It's a eye, and also it has a camera, and it also has 8-array microphone, and it has got a GPU device where you guys can test it. But what can you test and see? This is exactly what a sample that we did, and I've done this for a couple of customers too. If you're in an inventory, or if you're in a manufacturing offloading and things like that, you can actually count the number of people. You can say whether they are in a certain distance or not, or you can count the number of boxes. You can count any leakage. You can see whether is there any leakage or damage while they're offloading the equipments. Or in the manufacturing plant, you can actually count products. We couldn't show that because those are proprietary images, but I have some sample links in the resource section in the deck if you guys want to use that. This is an extreme combination of IoT, AI, and the cloud coming all together. That's the basic idea over here. So far we have been talking about what we are doing in the edge side, right? Now let's see how, if you have the edge, how can you guys take it and easily build applications or create whatever you wanted to create. That's the goal, right? I mean, as a student or a researcher, you might want to create something new and come up with something new. So we have this product called Azure IoT Central. And we have, what it does is like it allows you to connect, easily connect the device with, of course, security. You can actually go from data to value because it has an interface that you can see. If I have time, I'll show you guys later. And then you can scale your IoT edge devices, and you can also scale the implementation as needed. That's the beauty of this platform. It's like, so let's talk about, before IoT central solution, let's talk about how is a typical IoT solution would be. So on the left side, you will have a device, and the device would connect to IoT Hub. IoT Hub is your main center of attraction because it has all the security management, device control management, device configuration, all those are embedded in there. So that's the key part of it. Now, is that it is? No. In a real IoT solution, this is how we'll look at. Because you're building a device, that device gets manufactured somewhere, and then you have to provide like zero-touch deployment, like installation and things like that. So you need to have device provisioning service to figure out what that device is. And then usually you have an IoT Hub, and that stores the data in SQL, and then you send it to Event Hub, because Event Hub is there is a part of IoT Hub which is exposed as Event Hub, where you can do streaming analytics and store the data in either like Data Explorer is like your historian. Cosmos DB is where you store it for like API-based websites if you want to build and things like that. And then you send it out to Event Hub, because that's the last Event Hub is where most of the feed for data going out for other external applications or integrating with other applications. As you can see, it become complicated, but in reality, it becomes more complicated because this is what happens when the external applications come into play and you want to consume the data. Next part will be, if you look at it, what are the other dependent services that are going to be used? So you need all these functionalities on top of it. So it could be your user management, disaster recovery, device connectivity, scale, data processing, alert notification. So all of these putting together becomes complex. And that is where what we did is, so to build a robust industrial IoT application, we designed this software called Azure IoT Central. It's a starting way of for anybody to connect the device, send the data, model the data, what are its properties, and then immediately use the UI to visualization. Under the covers, we will plug everything else, the components that I saw you. So how you can onboard. So I'm going to talk to you about two ways. One is we call it APaaS. APaaS is Application Platform as a Service. This is IoT Central. This is the pre-baked system, and I'll show you guys the UI, how it looks like. Now the second part, if you think that no, I don't want to use it, yes, you can always go back to that complex architecture I saw. Like the basic components are IoT Hub, device provisioning services, Azure Stream Analytics, Data Explorer, SQL, and Cosmos DB. This will have an end-to-end IoT, industrial IoT solutions for you guys. And at this point of time, you can do any use cases in any number of ways. All the variations will, all these products will cover all those variations for you. Real-time, batch, everything, you name it. But if you want to make it easier, let's look at how you can make it much more easier, okay? Building an IoT solution means you need to have certain things. You need to have the edge devices collecting data, of course. You need to be able to do something. So you need the cloud infrastructure. And you also have to provide that infrastructure has to do something, and some other solution or some business users have to look at it to make value out of it. Otherwise, the system is no use, right? So taking that into consideration, this is how a traditional architecture would look like. On the left side, you see like we have different flavors of devices that can run, including we have RTOS, open source RTOSs you can use. We have a Azure Sphere, which is an chipset with TPM module in there to secure it. And you also have Azure SDK in C++, C, and then you have it in Java, C# and Node.js and few other languages. Then you have the IoT Edge Docker container module style as well. And that connects to IoT Hub and BPS. This is if you would have done it a year from now. And then on the right-hand side, you can see all the business application that the data gets consumed. Now, what do? The question mark is the center part. The center part is the most complex part. You are bringing in the data, there is a consumer, but you cannot show the data as it is coming in. You have to make some business sense out of it. This is where most of your logic processing or data analytics or ML analytics or AI analytics all happens in here. What do? These are some of the things that we need to do. How do I ensure the scale? What about HRDR? Where am I going to manage it? How is my hot store and cold store is going to be? Because given the IoT data is an immutable data set, as the data is coming in, depending on the industry, it might be large. So do you want to store everything in hot and pay? Or can you split that into some ratio and push the old data into a cold storage to save money? And how do you do data transformation and ingress and egress? How about the API access for other applications? If you have the data, you may want to share it with other applications, your other engineering or other organizations within an organization, so they can make use of it. This is where our IoT Central comes in play. So we made it extremely easy. So we took the most challenging bits that you need for the edge to manage and to build an IoT application. And we created an interface, a web interface that can actually do all those things for you. Like it has a dashboard, it has got analytics and rules. You can manage the users in there, like who gets what access. You can see the raw data. You can do device modeling. Device modeling is needed because every device may not have the same properties. So you might want to have a line one might have 100 sensors, whereas line 2 might have 150 of them. So you need to have that flexibility to collect in different ways. And then we cover all the hot and the cold path, and device ingestion, device management, which is the ingestion and provisioning. And then we also cover, this is the ingestion and provisioning. And then you can also see the bottom part here, like we cover all the elastic scale, high availability, and disaster recovery. This is basically what our IoT Central is. So you don't have to create a UI, you don't have to put all the analytics components together. We do that for you guys. So you will be able to connect and come to a website and do everything else in here. Now, not only that, we also allow you to extend from there, because this might not be only useful for you all the time. So you may want to export the data out and save it for cold storage, or you can export the data and give it to other systems to process something if you're doing machine learning, data science type activities. Make sense so far?
Oh, great.
Okay. Now, yeah, let me quickly show you that interface while you guys are there. So this is basically the one that I was showing you. This is called our IoT Central. So I have an MX chip. It's running in the computer here, and it is actually collecting your temperature, humidity, gyros, and magnetometer and accelerators. You can see the raw data that is coming in, which might not make any sense, but you have the capability to do this as charting. So you can see, like, I've been running it. I wanted to show you guys how I was running this one. So you can see this is at right now at my house, what is happening. And it also has, like, you can manage your templates, you can manage your devices, you can set rules, like if it's certain temperature goes certain, email Bala or something like that. You can also create a query. So this is a very interesting aspect. This is where, let's look at it. So this is where most engineers spend time on looking at, like, hey, what if analysis, or I wanted to do root cause analysis. Now I can't just do, I mean, you can use a state machine to do it, but still you want to be able to go back and analyze and see. This system will allow you to do that. So it'll store it, and you can zoom up and zoom down. I don't have much history to show you guys, but you see, right? Like, I can do this and it can go here, and I can actually select this and expand that. Like, I can do zoom like this, and I can say, oh wait, zoom in. So you can actually look at the values correspondingly, and you can actually check and see what's happening. Hey, is there any anomalies happening in here? What's happening? Or everything is going as per planned. And you can add all those things. You can also do some aggregations if you want, min, man, maximum, and all those things. This is also available. And then we also provide you a jobs engine. This is basically, let me save this. So jobs engine is basically if you want to update your edge devices with some configuration changes or something like that, you can batch the equipment into certain categories, like groups, and then you can publish it over there. Then you have device template. This is like, you can have different templates for different equipments. Here I'm using the MX chip, so I have the template in here. You can see all the templates property, what is the subtype is, and what is that, is it a telemetry or an event? You can specify that. You can specify device information properties to be set, and what the cloud properties has to be. And then we have a data export in here and administration. Now this This is where you can customize your UI, but you can also add your organization roles and users. How do you do device upload capability? There is a option like if you have large volume of data, you don't have to send it through IoT Hub. Rather, you can send it through and batch it and create like 10 MB file and upload it also. So these are some of the capabilities that we have. So how are we doing, Alberto, in terms of time?
Okay, I was on Bala. It's very, very, very interesting your presentation. Give me a second in order to ask for questions. ¿Alguna pregunta? Carol, esa es una pregunta. Okay. 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 Bala, thank you in advance on behalf of the university, and hope we work on this 4.0 with your carrying out projects and with your hand and continuous advance. Since you are I think you are a rock star in this area. We are thinking of a smart cities project and to ask your help in this development. If not, I don't know if it is possible to work with you maybe in the future. I don't know.
Yeah, if you need any help, email me. We can get on a phone call. I can definitely help you.
Okay, fine. I want to thank for your presentation, for your time, for all. Many, many, many thanks.
Oh, absolutely. No, thank you for having me, though. Appreciate that.
Okay, okay. See you in the next opportunity, and thanks for all. Okay.
Absolutely, absolutely. Thank you, everyone. Have a wonderful day. Thank you. Bye.
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 Conferencista me dijo que no podía, entonces quiero agradecer a todos los que estuvieron, digamos, involucrados este día, a Carol, Judy, toda la gente de logística que nos apoyó digamos, de una manera excelente. Mil y mil gracias también.